Hello, welcome to a new episode of Big Brother 161. In this episode we're going to explain where to obtain redstone, what to do with it, and we're going to talk about some basic elements, including how to assemble basic circuits. So let's begin. Here we will see three ways to obtain redstone. The first one is in ore form. Here we have two textures, the stone texture and the deep slate texture, where this slate texture can be found in the Y negative levels. With a normal pickaxe without the fortune enchantment, we can obtain anywhere from 4 to 6 pieces of redstone dust. And the deep slate form is pretty much the same. The second way is buying it from clerics. The cleric workstation is the brewing stand, and by the price of 1 emerald we can obtain 2 pieces of the redstone dust. And the third way is making a witch farm, where if we obtain a sword with looting 3, we can obtain plenty of redstone, as you can see here. So now let's review some of the elements. The first one is the redstone dust, and if we place redstone dust in adjacent blocks, we can see they make connections. The first thing to notice is that redstone dust placed by itself, it makes a cross pattern. We can see here if we place blocks in the 4 adjacent positions, they may be powered by the redstone. But just with right click, it passes from a cross pattern to a dot pattern. The second component, but maybe an unexpected one, is the opaque block. This may be stone, wood, dirt. And the second one is the transparent block, for example glass. In this experiment we can see we placed a redstone dust line, where we can see it makes a connection. What we should know about this redstone line is that it carries a signal if it is powered. We can see in this case it is being powered by the lever and it takes the power all the way to the lamp. But an additional feature about the redstone wire is that it also powers the block just under that wire, as long as that block is opaque, as you can see here. In the case of a transparent block, for example their glass, it doesn't. As you can see these lamps, only the ones adjacent to an opaque block are lit. But the redstone lamp that is adjacent to the glass is not being powered. With only a redstone dust and a stick, we can craft the next component, the redstone torch. This component is considered a power source. We can see in this example, a redstone wire is carrying the power that the torch is providing. As you can see here in the right, the first redstone piece has a power of 15. And as the redstone wire is carrying this power, it's being reduced by 1 power point for each block, eventually reaching 0. Another main characteristic about the redstone torch is that if the block where the torch is being placed is powered, then the torch will be unpowered. This allows us for a very interesting feature. Here we can see that if the block is being powered, then the torch is being unpowered. When the block is being unpowered, then the torch is powered. So in practical terms, here we have a redstone inverter. A very different thing happens when the torch is placed in a transparent block, as you can see here. What counts as a transparent block? We can see here glass or slabs. And you can actually make this small experiment to determine if the block is transparent. Here I'm trying to power this block, but the torch doesn't turn off or on, it just remains on. Other examples of transparent blocks may be low slabs, top slabs, stairs in any of their forms, or leaves, etc. The next power source I want to introduce is the redstone block, where we can craft it with 9 pieces of redstone. The difference with the redstone torch is that this source can never be turned off. And if we connect it with a redstone line, it may carry power, and the first piece is receiving a power of 15. The redstone lever. Now, this source has an intrinsic property that it can be turned on and off, different from the redstone block or redstone torch. Levers can be placed on any of the 6 sides of a block, and they work pretty much the same. Another characteristic is that the torch is also going to power the block over which it is placed. So it is not necessary to connect the redstone directly to the lever. You can connect it to the block. And you can have something like this. You can also place the redstone just under the block, and it may be powered also. The redstone button. So this one basically comes in two forms: stone buttons and wooden buttons. The stone buttons come in two forms: the normal stone button and the black stone button. And wooden buttons come in 8 varieties, the 8 varieties of wood. So in a technical aspect, the main difference between stone and wooden buttons is their pulse duration. Wooden buttons emit a pulse duration of 15 ticks. What is a tick? A tick is practically a tenth of a second. So 15 ticks is equivalent to 1.5 seconds. And the pulse duration of a stone button is 10 ticks, or its equivalent 1 second. As you can see here, it is shorter. Now the redstone repeater. As we saw earlier, a redstone wire can only take power to a distance of 15 blocks maximum. So as you can see here, what can we do if the power runs out? So the property about repeaters is that if it receives a signal greater than 0 here in the back, or the in connection, it will always emit a power of 15 in the out connection. And in case of a long redstone wire, where you see that the power runs out, you just need to place a repeater and the signal will continue. Another function of the redstone repeater, you can see it in the indicator over here. It has 4 positions. As you know, redstone repeaters don't emit their power instantaneously, but actually this indicator tells how much the delay will be. In the first position it is 1 tick, in the second position it is 2 ticks, 3 ticks, and the final position it is a 4 tick delay. Here you can see 4 repeaters, each one programmed in its position, and as you can see, the redstone response on each of them is different. We can see here in the second experiment, we have 2 lines of redstone repeaters. One of the lines are set in the first position, and the other line is set in the fourth position. You can see the response here is very different. And the final feature we want to discuss about the redstone repeater is about the locking system. As we saw, a redstone repeater emits a 15-powered redstone signal if it receives any power above 0, or any positive signal. If we place another repeater on the forward connection towards any of the signs of the repeater or auxiliaries, and we power this second repeater, we can see its indicator adopts this bedrock texture bar appearance. This indicates the redstone repeater is locked. As we can see, this indicator can also be moved throughout these 4 positions. But what this lock position indicates is that the repeater will continue to emit the signal that it was emitting at the time it was locked. Regardless of whatever the signal in the in position is. And now it is ignoring any inward signal it is receiving until the lock is released. So now we release the lock. And then let's turn off this lever and put the lock again. You can see the out signal is off, and regardless of the inward signal, it will remain off until we release the lock again. Now the redstone comparator. This is probably one of the most uncomprehended redstone elements there is, and it probably deserves, because of its complexity, its own video. Like the redstone repeater, it emits a positive signal if it receives a positive signal. But the difference is that it replicates the signal it is receiving. Here you can see in the in position it is 13, and the out position is 13. We can also place a block in the out position of the comparator, and we can see the comparator powers the block, and the block powers the redstone. Regardless of the block, the power also translates. You can see here 13, and the redstone is also 13. Now, the main characteristic about comparators is that it compares 2 signals. So, in this experiment, it is receiving a power of 13. But remember that comparator has 2 additional connections, the auxiliaries, on each of its sides. So, this is the in position, this is the out position, and each of its sides are the auxiliary positions. You can see here the in is power 13, the auxiliary is power 12, and the outward position is 13. But what if we increase the signal? 13, auxiliary is also 13, and it decides that the out is 13 also, a positive signal. But now let's make it 14. This happens. Now the outward signal is 0 or off. So this is what the comparator does. It compares the two signals, the in versus the auxiliary. And if the auxiliary is less or equal to the in signal, then it will decide that the outward signal is going to be positive. The second main function about the comparator is the subtract mode. So doing right click in the comparator, we activate it. You can see this light. So let's repeat the experiment, and in the in position we will have a 13 power. Now in the auxiliary connection, let's give it a low signal, 10. And now you can see in the out, it is 3. 13 minus 10, 3. Now let's try with a different signal, 12. You can see here, 13 minus 12 is 1. So now let's try 13. 13 minus 13 equals to 0. And of course any signal greater than in, it will give us a result 0. The third and probably the most used feature about the comparator is obtaining a signal proportional to how full a container is. For example, this chest. We may also use dispensers, droppers, barrels, any other block that can contain items. So here, by the time being, the power is 0 because the chest is empty. But what if we place the first item inside? We can see here it is minimally full, so we obtain the minimal signal. So now let's fill up a third of the container. We can see here the power is 5, 5 out of 15. Now let's fill up the second third of the container. We obtain a signal of power 10. And if our container is completely full, we obtain a full signal, 15. So the comparator will emit a signal proportional to how full the container is. The comparator can also take a signal across a block. So we can hide the redstone circuit here behind the wall and have the container in front of us, and we will not have to see any of the circuit. Now, comparators can also take a signal towards an entire line. The first one is receiving a power of 12. And as we can see here at the end, the power output is also 12. But comparators can be quite expensive, so we can have this arrangement, where we have redstone comparator block, redstone comparator block, redstone comparator block, and we can have the same effect. The same power signal will be carried out towards the end. Now, before continuing, I want to take a small parenthesis to explain what strong and weak powered is. As we saw, a redstone wire can take a signal towards the distance. And of course, a block may be powered by redstone, as we see here. But that opaque block cannot continue to power the redstone wire that is adjacent to it. Why is that? We can see here that the block is being weakly powered by the redstone wire, because this is the way the redstone wire works. It weakly powers adjacent blocks, and in order for the block to power other redstone wires, it needs strong power. There are two ways to get over this impasse. One way is to allow a redstone repeater to directly power the block. You can see here, actually the signal continues over the block, and it is this characteristic that repeaters and other components have. They strongly power any block in the outward position. This is strong power. But repeaters only require weak power to function, and it is what we have here. Redstone is weakly powering this block, then the block is weakly powering the redstone repeater, which is just what it needs, and the signal continues. we have this final arrangement where the lever strongly powers the repeater strongly powers this block, and the block can pass on the signal towards the redstone wire, as we see here. Pressure plates. The first one we're going to see is the stone pressure plates. They come in two varieties, normal pressure plate and blackstone pressure plate. What this plate does is detect the presence or absence of entities. As we can see here, no entity means a zero signal, and the presence of an entity means 15 signal. The wooden pressure plate. These pressure plates come in all the varieties of wood, as we see here. They do pretty much the same thing as the stone pressure plate. No entity means signal 0, and the presence of an entity means a power of 15. But what is the difference? If I throw on an item on the stone pressure plate, it detects no signal. But if I do the same thing with the wooden pressure plate, it actually detects the items. Now, the heavy weighted pressure plate, or the iron pressure plate, is this one. If I place the first entity, it lights up with a power of 1. Now if I continue, 10, 11, we can see this plate emits an additional power level for each 10 entities I place over it. The light weighted pressure plate, or the gold pressure plate. If I place an entity, it emits a power of 1, the second entity emits a power of 2, 3 is a power of 3, and as you can see, unlike the iron pressure plate, this one emits a power level for each of the entities it detects. This includes items. There are many components, so I decided to divide this video in two parts, so join me on the second part where we will be reviewing the rest of the components. This has been Brother161, and remember, I will be watching